Well, hey, all you cool cats and kittens, welcome to your last lesson of the week. This is going to be a pretty short one. I'm only going to go through one sample problem. Please make sure that you are going over the textbook questions, that you are trying those out, finding the solution. And after this, there is actually a virtual lab for you to do. Isn't that so exciting? You get to click a button and pretend you're doing actual chemistry, just like we did at school itself. So to start today, we're going to look at the molecular formula of hydrates. Okay, we've looked at empirical formula, we've looked at molecular formula, and now we're just going to take it one, not even a step forward, but like a step to the side, adding on a little zhuzh. A 50-gram sample of barium hydroxide hydrate contains 27.2 grams of barium hydroxide solid. I'm asking you to determine the molecular formula of the hydrate. So what do we know? We know that the chemical formula of barium hydroxide is BaOH2. Now we're told it's a hydrate, but we do not know what the coefficient of the hydrate is going to be. Okay, so that's what we're trying to find out here. We know that the mass of the barium hydroxide solid itself is 27.2 grams. So what we need to find out is what proportion of that was actually water. Well, I'm going to do it over here. So the mass of the water would be the mass of the sample itself, subtracting the mass of the barium hydroxide, which would leave 22.8 grams. Now, you've probably jumped ahead of me. You said, hey, we know the masses. I bet we could determine the number of moles. And boy, oh boy, are you correct. And this is why you guys are my favorite. So we can find the number of moles of barium hydroxide by taking the mass of it divided by the molar mass of it. Okay, so 27.2 grams divided by, when you calculate the mass, the molar mass of barium hydroxide, the whole compound, we get 171.35 grams per mole. Okay, and that gives us 0.159 moles. Let's find the number of moles of water that are present in this sample. So again, we'll take the mass of the water present divided by the molar mass of the water. So 22.8 grams divided by 18.02 grams per mole. And that gives us 1.27 moles. Just like for molecular formula, we're going to identify empirical formula, the lowest of the molar amounts, and we're going to divide both of them by that value. Okay, so that gives us, well, that's a 1, and 1.27 divided by 0.159 gives us 7.99, or I can round that, to 8. So what does this tell you? The ratio of barium hydroxide to water is 1 to 8. So for every mole or formula unit of barium hydroxide, there are 8 formula units of water. So that means that we would write it as BaOH2. Now remember that dot for hydrates. So that's going to be an 8 H2O. And what would the actual name of this compound be? Do you remember how we name hydrates? So we'd have barium hydrate. Then we take the prefix here, barium hydroxide, octahydrate. And guess what, guys? We're done. That's the end of the lesson today. A whole 5 minutes. So try another sample of this, look in your textbook questions, and then go on to do that virtual lab. That is an assignment that's due. And then you are done learning new things for the week. So you can go ahead and try the practice quiz and the final end of week quiz when you're ready. Thanks for stopping in, and I'll talk to you guys on Zoom or on our discussion board.